Good morning. Welcome to Physics World. Today we discuss about chapter 8, electrical conductivity of liquids. Every day in our life we see so many things. Like we use refrigerators, televisions, washing machines, etc. And all these electric appliances works based on electricity. The question is how they're getting the electricity. Yes, from the main supply, but from the main supply they're getting electricity through cables. And if you just get into the cables and you check, you get to know that inside the cable you have copper wires. Of course, copper wires are insulated by plastic material. So these copper wires are the main carriers, main canals I can say, which allow the current to pass from one point to the other point. And copper is a metal. In the chapter 4, metals and non-metals, we have discussed that all metals are good conductors of electricity. Conductivity is nothing but the strength of demonstrating a property. Electrical conductivity is a demonstration of electrical nature, allowing current. So all metals allow current, and you know that most of the metals are solid in nature. Now my question is that do you have the same electrical conductivity in liquids? Or all the liquids have the same electrical conductivity, or there is any difference between the liquids in terms of electrical conductivity? So to know answers for all these questions, let us start this chapter. So if you go to the village side, you heard this type of news many times that the farmers, when they're switching on the electric motor, and when switching on the electric motor with wet hand, they got electric shocks. Why they're getting electric shock when they touch the electric mains at the motor with wet hand? Similarly, your elders always suggest you that stay away from the electric heater which is used for heating the water. Why? There is a reason behind that. These two examples tells you that there may be a possibility of electrical conductivity in liquids. So before going to those properties of liquids, let us recap the electrical conductivity of different materials, especially solid bodies. So to understand that, let us do a demonstration. So I am preparing a simple electric circuit. A simple electric circuit. Here we will going to test that I'll give so many materials to you. In those materials, which material is good conductor of electricity and which material is bad conductor of electricity, we have to check, right? So what we do, you take a cell or a small battery, take a cell of 1.5 volts enough. So take a cell of 1.5 volts. It's a cell which is having 1.5 volts of voltage, and this cell is connected to a cardboard. This is a cardboard, and these are the connecting wires, and these wires connected to a electric bulb type material. This is called LED. Soon I will tell you what is the advantage of LED and what is LED. So this LED is connected, and this LED now, from the LED another electric wire comes, and this electric wire again connected to cardboard using two drawing pins like this. So the circuit is constructed. Do you think the circuit is completed? No, circuit is not completed because it is open. You have to close the circuit here. So to close the circuit, what we do, initially we will take the help of safety pin. We will take the help of safety pin. This is the safety pin. Yeah, right. Now this is safety pin. These are wires. Any copper wire you can take copper wires, that is cell. I already written LED. This is cardboard. Now, if you see the simple circuit clearly, actually it's not closed. If you want to make it closed, what you have to do? You make the safety pin to touch the other end of the cardboard. That is the drawing pin. So whenever the safety pin touches the drawing pin, immediately the current flows in the circuit and LED glows. LED means light emitting diode. It glows. So it itself says that yes, the safety pin is a good conductor of electricity. Now test the same electrical conductivity of different materials, like number 1, a strip of paper, 2, straw, a drinking straw, 3, pencil, 4, rubber, 5, plastic, 6, iron rod, a simple thin iron rod, etc. So when you check all these things and replace them, replace the safety pin with all these items and check the electric conductivity and understand which are good conductors of electricity, which are bad conductors of electricity. And if you do demonstration of with all these items, then you get to know that strip of paper is a bad conductor, doesn't allow the current. Straw, bad conductor. Pencil, bad conductor. Rubber, bad conductor. Plastic, bad conductor. Iron, good conductor. So this demonstration, a simple electric circuit, tells you and give the advantage of checking the types of materials and then their conductivity. Now this demonstration is understand. Now coming to our main point of the chapter, electrical conductivity of liquids. Now how would we test that whether the liquids have conductivity or not? So before checking the conductivity of liquids, let us understand what is electrical conductivity. So electrical conductivity is nothing but allowing flow of electrons. So you know that current is because of flow of electrons, or simply you can say allowing current. So which metal has the feature or the nature of allowing more number of electrons, that metal can allow the current, and that metal can be called as good conductor. And which material doesn't allow the flow of electrons or doesn't allow the current, we can say it's a bad conductor. So if you take the iron, copper, all these metals are good conductors of electricity because they are allowing huge amount of electric flow. Okay. Now come to our main point, electric conductivity of liquids. We will check by constructing a simple electric circuit as before to understand the conductivity of liquid. See the board. Here, once again, I will create a simple electric circuit. A simple electric circuit. See. So what we do here, take a rubber cap. It's a rubber cap. In the rubber cap, fix 2 metal pins. Any 2 metal pins, iron pins, aluminum pins, copper pins, anything, brass pins, anything you can take. 2 metal pins. And from these 2 metal pins, take 2 wires, 2 copper wires, and 1 copper wire is connected to a cell again. It's a cell, and this cell is connected to an LED. How we connected earlier, an LED, and this LED now is connected to this copper wire and closed like this. A simple circuit. Over. So copper wire is connected to cell, cell connected to LED, and this is LED, and these two are metal pins. This is rubber cap, It's an insulator. Rubber cap is insulator, but over the rubber cap you have the two metal pins connected to copper wire. Now, do you think that LED bulb glows? No, because it's not completed. So what to do? What you have to do? You have to touch, or you have to make these two pins contact with each other. So you use the two fingers and hold them and make them to touch with each other. When they touch with each other, immediately the bulb glows because the circuit is completed. Okay, you tested, circuit is working. Now you have to test the liquids. So what to do? First of all, you take a small container, and inside the container you fill water. So here you fill water. So this is water. So inside the water, the two pins are immersed. So in the container you have the water. The two pins are immersed. Now what happened to LED bulb? Does it glow or don't glow? Yes, it glows. When it glows, you can say that yes, water is good conductor of electricity. But wait, which type of water? Then you get surprised at what I am saying, that which type of water? Yes, we have mainly two types of waters. One is distilled water, pure water without any impurities. The second one is the normal drinking water, what we drink, which has some impurities. Impurities in the means, I want to say you that impurities mean the water is having some salts, some minerals. So that is called water with impurities. So distilled water is a pure water. Here what the water have used, it is not distilled water. It is having some acids, some minerals, or it is a drinking water, which one we daily drink. So it's got good conductor of electricity. Now replace the water, drinking water, with the distilled water. Distilled water in this container. Now you check. LED doesn't glow. Why? Even though it's water, it doesn't glow because I told you, because it's pure. Pure water is always bad conductor of electricity. So it is bad conductor. Bad conductor of electricity. So this two examples tells you that yes, liquids also having electrical conductivity nature, but not all the liquids, and all the liquid doesn't behave the same way. Now to move further, replace the distilled water with the different liquids listed here. I am listing here. The number 1, coconut oil. Replace the distilled water with coconut oil. Number 2, kerosene. 3, mustard oil. After mustard oil, lemon juice, sugar solution. So all these liquids, use them and replace the distilled water and check the electrical conductivity of the liquids. So in these two simple electric circuits we studied earlier, we have used LED instead of the small electric lamps. Why we have LED? The first advantage is that LED can glow in less voltages also. If you send small current, that is enough for the LED to glow. If voltage increases, LED glowness also increases. So the advantage of LED is that a small amount of voltage also it glows. LED full form is light emitting diode. Light emitting diode. Diode means the electric component having two terminals. Di means two terminals. So it comes like this. Two terminals. These two terminals, if you check, one is longer in size, one is shorter in size. The longer one is called anode, positive terminal. The shorter one is called cathode, negative terminal. LEDs are mainly developed using semiconductors. And one popular LED source is Ga gallium arsenide. Gallium arsenide is a material with which LEDs are made. And when you want to connect the LED in the electric circuit, the anode is connected to in the electric circuit to the positive terminal, and cathode is connected to the negative terminal of the in the electric circuit, so that the simple circuit starts working. So we have discussed that distilled water is a bad conductor of electricity. It does not allow the current. Now, still if you wanted to allow the current in the distilled water, what will you do? There is a technique. Through the technique, we can transform the poor conductor into a good conductor. So, again construct the same simple circuit. In the earlier case, we have checked the we have checked we have checked liquid conductivity in the earlier simple circuit. You construct the same simple electric circuit. So in there we discussed that you have a container. Inside the container you have the liquids, and inside the liquids the two metal plates are immersed, and we check the conductivity of the liquid. So take the same electric circuit. Now, as you know that distilled water is a poor conductor. Now take the container with the distilled water. Now add some salt to it and mix the salt with the distilled water. Stir using a spoon, and so that the salt is mixed with distilled water, and put that container with the distilled water plus salt to that simple electric circuit, so that the two metal pins are immersed in this solution. What happens? Bulb glows. That means now this distilled water has changed its nature because of the salt. Now do the same test with distilled water plus copper sulfate. Distilled water plus copper sulfate solution, and test. Again bulb glows. Next, distilled water plus lemon juice solution. Again LED glows. So whenever the distilled water is disturbed, or I can say to change the nature of distilled water, when you add salts and copper sulfate and lemon juice, immediately it's showing the conductivity nature. So this demonstration tells you that if you take water or any liquid, their conductivity increases because of acids, base and salts. So if you want to increase the conductivity more and more, just add either acid or base or salts to the particular liquid. So far we have discussed about conductivity of different metals and different liquids. Now do you think that do we have electrical conductivity using vegetables? Yes, we have electrical conductivity using vegetables. Now we're going to tell you a simple demonstration with which it will be clear to you that electrical conductivity will happen using vegetables also. Now take potato, cut the potato into two pieces, and the potato should look like this, the half part potato piece. So potato is there. Now take two metal pins, pierce into the potato. Now this first metal pin connected to a copper wire, and this copper wire connected to an LED, and this LED connected to a simple battery, and again the other end of the battery connected to the second metal pin on the potato surface. This is a simple electric circuit. You can do it at home also. and I'm suggesting you to do this simple experiment. So this is negative terminal, this is positive terminal. Okay, now what happens? So according to me, the bulb has to glow. Does it glow? Initially there will be some disturbance. Sometimes bulb glows, sometimes doesn't glow. Maybe the difficulty in constructing the electric circuit. So once again check all the connections, see that no loose connections are there. And immediately if you see, observe the electric circuit again, the bulb glows. So that glowing of bulb tells you that yes, the current passing through the wire, through the battery to the wire, to the metal plate, inside the metal plate to the potato, through the potato to the other metal plate, from the other metal plate to the copper wire, and current goes to the LED. So what I mean to say is that current is passed through the potato. That's why bulb is glowing. Why it is passed like that? What is the reason behind that? The reason is chemical reaction. Inside the potato, so many chemicals are there, and those chemicals reacted and they have converted chemical energy into electrical energy Due to this, the current flows in the electric circuit and bulb is glow. Now, is it true for only potato? Not at all. You can test this simple electric circuit with other potatoes also, with other vegetables also. So try with other vegetables like lemon, carrot, brinjal, tomato, radish, etc. and check the strength of the electrical conductivity of those vegetables. So far we have learned to test the electric conductivity of different materials using cell. Cell is the main source for the electricity. Now my question is, can we produce electricity without cell? Is it possible? Yes, it is possible. In science, everything is possible. The only thing is you should have a constructive idea, an innovative thought, then everything is possible. So here I am going to tell you about how to produce electricity without a cell. In another way I can say, how to make our own cell so that we can produce electricity. Yes, our own cell is called electrolytic cell. This will be happen because of chemical reactions. Earlier in the example also told you, chemical energy can be converted into electrical energy. So taking that principle into the mind, we are doing this experiment. So what we do here, take two containers like this, and in these containers keep two rods, or I can say two plates also. You can take two rods, cylindrical rods, or two plates of metals. Which metal? One is copper and other one is zinc. Copper and zinc. So the two containers, you have two rods of copper zinc and copper zinc. Now in the first container, the copper rod or copper plate is connected through copper wire to the LED, and other end connected to the zinc. Okay, and this copper again connected to the zinc like this. Now see, there is no contact between copper rod and zinc rod in the container. They are separated. They separated by at least 1 centimeter distance. So there is no connection between them. No connection. What to do? Now in this container, pour dilute sulfuric acid. Dilute sulfuric acid. This sulfuric acid you can get anywhere in the market, any chemical shop. If you go, you can easily find. or in your school, if the chemistry lab is there, you can ask your chemistry teacher, lab assistant to have this dilute sulfuric acid. So what happens? When the two containers are filled with the dilute sulfuric acid, these two rods, copper rod, zinc rods, are actually immersed in this solution. Now observe carefully what happens. Now slowly, gradually what happens, the LED bulb begin to glow. And we have not connected any cell, still the bulb begin to glow. That means the passage of electrons are happening. That means current is in the circuit. How? A simple chemical reaction. The simple chemical reaction is the zinc rods, which are in the dilute sulfuric acid, they dissolve in the acid. When they dissolve in the acids, then there will be positive ions and electrons are created. And because of positive ions and electrons, current moves from copper rod to zinc rod. Copper rod to zinc rod. Current flow, and that current goes to LED, and LED starts glowing. So this beautiful experiment demonstrating you that we can also create our own cell. Have you ever seen some vessels which are shining? Like a simple example tell you. See your pad, the clip of your pad. The clip of pad shines. Why it shines? Because it is metal coated. If you scratch continuously on the clip, you can see that the layer will come out. So that tells you that there is some coating happened on the clip, on the iron clip. Similarly, if you see the safety pins, if you buy the new safety pins there, they look shiny. But after a few days, you see that the shining effect will be gone. And if you see some statues which are coated with silver, which are coated with the gold, it looks very shiny. Now here my point of question is that how the people able to coat that metals like what you call gold coating, silver coating, or what you call aluminum coating, and the different iron materials. How it is possible? Are they coating just like how you coat the paint on the wall? No, not at all. There is a specific method to do metal coating on the different metal substances. And the special method is called electroplating. So this coating will happen due to the flow of charges, due to the current. Now I'm going to explain you a simple experiment where you can have the electroplating. This is also can be done at home, but little care should be taken. So it should be done under the guidance of adults. So what we do, take a container, take a big container. In this container, take a copper plate. You take a copper plate, or you can take a cylindrical copper rod, no problem. Now this copper rod is connected to a copper wire, and this copper wire is connected to a key. It's a key, or you can say switch. Now this key is connected to a cell. I can say you can take a cell, or you can take a battery also, no problem. So I have taken a battery. So the negative terminal of the battery is connected to a wire, and the wire is connected to a key like this. It's an iron key. It's an iron key. Key. This is copper rod. Now what I want to do here, I want to tell you that how the electroplating happen, and I want to tell the how do you do metal coating on other metal substances. And here metal substance is key, iron key. Now after a few seconds you can see the copper coating on the key. How it is possible? So after keeping the copper rod and iron key, keep some small distance between them. Now fill the container with copper sulfate solution. You have to fill the container with copper sulfate solution. This is copper sulfate solution. Fill the container with copper sulfate solution. Okay. Then once everything is over, how I demonstrated you after finishing everything, now close the key. Whenever you close the key, automatically from the battery current flows, and observe what happening. After few minutes, you can see the key is changing its color to brownish, and that brownish color representing that copper is coated on the iron key. This is what called iron electroplating. Now the question is how the copper layer formed on the iron key. Yes, I will going to show a chemical reaction. So here is the copper sulfate, CuSO4. It changes, it splits into ions and electrons. So one is copper ions, Cu plus 2, and other one is sulfate ions, SO4 minus 2. Cu plus 2 goes to negative terminal. Why it goes to negative terminal? Because this is positive ion plus 2, and SO4 minus 2, which is negative ion, it goes to positive terminal. Now in this experiment what happened? So here the solution is copper sulfate solution. It splits into copper ions and sulfate ions. Now now this copper ions, which are positive ions, they move towards the key because key is connected to negative terminal. So it attracted by the key, and the copper layers form on the key. Now the sulfate ions, what happened? The sulfate ions are negative ions, they move towards positive plate. Positive plate means copper. And after moving towards the copper rod, they again creates copper sulfate atoms, and these copper sulfate atoms again added up to the solution. So in that way the process continues, and after some time the iron key is fully coated with the copper, changes color to brown, and this is what called electroplating. Whenever you're doing electroplating to a particular metal body, you should take care of some important points. The first point is the material, or I can say the body, metal body on which you want to do metal coating. The body surface should not be greasy. Should not be greasy. Then if you want to make the electroplating, if you want to make the coating also, don't stick to the surface. The second one, the body surface should be rough, so that the coating will be sticked permanently. The third one, concentration of solution should be perfect to do electroplating. The fourth and last one, current should be same in all stages. Then only you can have uniform electroplating on a given material. So we have understand the advantage of chemical reactions with which we can do electroplating. Now here electroplating also give many advantages, so many applications to us. Actually, why do electroplating to different substances like different idols or statues or some what you call utensils? Why do electroplating? They do electroplating because to protect the material which is inside, to protect the material from the atmosphere, moisture and carbon dioxide existing in the nature. Especially if you take the iron, if you keep the iron open to the air for some days, you can see iron gets rusted. So to protect iron from get rusting, you have to do plating to the iron materials. So generally iron is protected from this rusting and also called corrosion. Iron is protected from corrosion by electroplating with nickel and chromium. If you see the wheels, the rim, if you see the wheels of vehicles, and to the wheel, if you see the rims are very shiny. So to those rims actually made of iron material, which are coated with different type of metals like nickel, chromium, silver, according to the interest of the customer and the company. So when they look shiny means the first is the look, you're giving more effect to the look. The second thing is you're protecting the inside material from rusting and corrosion. Different machinery parts also protected from corrosion by coating especially with chromium. Machinery parts are electroplated with chromium. Similarly, ornaments, jewelries are also coated with silver and gold. And in chapter 4 also we discussed that silver and gold are do not interact with the oxygen in the air, so that they will keep those ornaments shiny, beautiful for a long time. Iron, when mixed with the zinc, become very strong, and this mixture used for bridges and automobiles. So these are some applications using electroplating. Now find out some more applications of electroplating by reading the textbooks, by reading some other reference books.